Do we have the recordings for the last week?
Yeah, once. So, just introducing myself for those who are attending the first time, right? So, hello everyone, I'm Sai Venkatakrishnan, a PhD scholar in the Department of Computer Science and Engineering at IIT Madras. So, this is week 2 live session for the course Blockchain and its applications. And we'll be discussing questions posted in the forum, as well as any questions you have, you can post it in the chat box or unmute yourself and ask. So let's get started. Yeah, someone was asking about Bitcoin. Doubt.
Yes, sir. Sir, what is Bitcoin ecosystem, sir?
What is Bitcoin ecosystem? That's like, what are you expecting from that answer? I'm not sure. Ecosystem as in like who are the users and all those things, is it?
Okay, sir.
Okay, so like what I will do first is for the first half an hour, right? I will discuss all the questions posted on the forum. I'll try to wrap up the questions first. Okay, which was not completed the previous week, so that we'll wrap that first. And any questions you have with respect to the first 2 weeks, please ask with respect to that. And once that is over, we can start looking into Bitcoin. Okay, does that sound good?
Yes, sir, that should be fine.
Okay. So that because like if we keep on jumbling up questions and asking like Bitcoin and then some other topic, right? The flow of explanation gets cut and it leads to like wastage of time. So I thought we can better streamline it. So the week 1 and week 2 questions that you have posted on forum, I'll be discussing those first. So I remember we discussed question 16, I guess. Which programming language does the blockchain technology use? Okay. So the answer to this is there are multitude of technologies. So there are different programming languages. So for if you take Bitcoin, right? So any blockchain, right? Any blockchain thing you take, right? There are two programming languages that you'll be using. So one is for your consensus, okay? That is sending all the messages across all the nodes and those TCP modules and all those things, and then validating those nodes, validating the blocks in the blockchain and all those things. And the second type of language that you will be using is somewhat like a script or a smart contract. Okay. So these are actually on chain, as in these will be stored as part of your blockchain, this scripts and smart contract, whereas this consensus code is something which your computer or your system would be running, right? And this consensus code, it be in say like C++ or Python or Go. Okay. And this will be in charge, in turn this will be actually executing these smart contracts. Okay. So the smart contracts as such will be some specific language, and it will be running on an interpreter. And this interpreter, everything would be part of your consensus code. So those who want to delve into blockchain, right? If you are, if you want to develop some distributed application like based on the smart contracts, you should be learning the smart contract language with respect to that blockchain, right? So for Ethereum, they use some minimalistic programming language, right? I'm not sure of the name.
Solidity.
Ah, yeah, Solidity. Yes, thank you. So they use Solidity. So you should be learning that language, and you should be developing applications in those. If you want to get into how the blockchain is maintained and those consensus mechanisms like proof of work and changes to that, right? For that, you should be looking into the consensus code, the actual code which is running in each node, uh, right? So this is what the code with respect to each blockchain is. And usually what happens is, say if you want to code in the smart contracts in Ethereum, you need not always learn Solidity, there might be wrappers like say if you write something in Python, and there will be some software package which will convert the Python code into the Solidity. Okay, so this is what the scope of programming languages is. So if you first, you should zero in on the blockchain technology that you want to build applications on, and then you should look at the languages. So there is no like universally one single language that is used in all the blockchains. That's not the case. Any doubts in this question?
So in
Sir,
this course,
related
like,
to consensus. Please explain it.
Okay, so consensus code is nothing but so in the blockchain, right? You will be having the proof of work in Bitcoin, right? So you will be not proof of work actually. So um, okay, so the consensus rules is nothing but one, you should be checking if say Alice is sending some 10 bitcoins to Bob, okay, and you should ensure that Alice doesn't double spend these bitcoins. As in, like, you should check whether Alice has sufficient bitcoins in their account before sending it to the receiver. So, like in a normal banking transaction, what checks um, would you be implementing before you finalize a transaction? So the bank will check whether, if I want to send some money to you, the bank will first check whether I am a valid user, right? It will check my account number, then it will check whether I have sufficient balance in my account, and then it will check whether the receiver's address is correct and all those things, right? So all those things would be part of your consensus code with respect to Bitcoin. So it will check whether that signature is valid, uh, whether the that hash of the transactions, everything has been properly calculated and all those things, right? So all those will be part of your consensus code. As part of your script or smart contract, it will be some other logic, right? So for example, in Bitcoin script, if you take, which is running on the chain, that will be uh, the that will be with respect to, like, say if I want to send some money to you, this Bitcoin script will contain the public key of your account, and it will contain some signatures like that, cryptographic signatures and all those things. So the script will just authenticate the sender and the receiver. We don't do nothing much than that. Whereas the consensus code over here, this will be in charge of validating whether the transaction is really legal or not. It will check whether I have sufficient balance or not. And this consensus, so in Bitcoin, like, once you generate a block, you should be adding it to the blockchain, and you should propagate that block to all the other nodes so that everyone has the same maintains the same blockchain. So all these things would be part of your consensus code. Yeah, is this clear?
Yes, sir.
Right. So in that case, let's move on to next question. What's the real-time info of the stakeholders? Okay, so this is what respect to week one, I guess. With Professor had mentioned something with respect to the petroleum supply chain management. Is there any doubts in this question? I don't. The question is pretty straightforward. So real-time info is just like they want to maintain some accounting or something based on this petroleum, the oil that is being sold and brought in the market. So all those transactions, they have to store it in real time, and they don't trust each other, as in who is in charge of the overall ledger, right? So in that case, they use a common whiteboard, which is the blockchain, to store all these transactions, and everyone is in charge of ensuring that the blockchain is correct and it's not tampered with. Any doubts in this question? It's a pretty straightforward question.
No, no.
Okay. So here, the next question someone has asked, how is it possible the info that is published on the blockchain is not denied? Okay, so this is what is actually they use a scheme called digital signature. Okay, so this was covered in week 1 or week 2, I guess. So digital signature is nothing but, say I am a user, say Alice, and Alice is adding a block to the blockchain. So so this is an existing blockchain, and it's adding a new block over here. And what it will do is it will sign this. It will this block will include the sign Alice's digital signature. So the digital signature is nothing but, say if I take the public RSA based digital signature. Okay, so RSA based signature, what it will do is it will generate a public private key pair. A public and private key. The private key should be kept secret, and the public key will be known to all the other users in the network. Okay. So now what Alice will do is it will sign this block. So this entire block would be signed with Alice's private key. Okay. Or instead, like you can get the hash of this block actually. So this entire block, you can get a block hash and you can encrypt that hash using the private key. And now when someone wants to ensure, someone wants to check like who published this information or something, like the hash would be there and also a signature would be present along with this block. So what they can do is they can take the public key of Alice and apply it on the signature. So the public key plus the signature would give out my original hash or whatever I encrypted using Alice's private key. So it's basically the key concept over here is there is a unique public and private key pair. The private key is something which only Alice will know, and if Alice uses that to encrypt the block or something, encrypt the message, right? Then anyone else who is able to decrypt that message using Alice's public key can be sure that Alice had used his private key only to encrypt that message. And since the private key is known only to Alice, we are sure that it was Alice only who had signed that message or who has posted that message on the blockchain. So in that case, Alice later cannot deny that I didn't post this message on blockchain because this public and private key mathematical properties ensures that it was Alice was the only person who would be able to publish that message on the blockchain. So through this digital signature scheme, the information which is published on the blockchain is cannot be denied later on. So based on the assumption that the private key is secure and it's known only to the signer. Any doubts in this question?
Yeah, I have a question.
Sir, I have a doubt.
Yeah.
Okay.
Yeah, I think
Sir,
there's
I
a
have a
collision.
doubt. Everyone has their each other key, right? So where they have to store, sorry, they have to store the public keys before using it because there's a lots of data that is inside the public key. So where they stored it?
where will be storing the public key? Is it? I didn't get your question.
Sorry, sir.
No, I didn't get your question. Where will be storing the public key?
Sir, yes, sir. Everyone has it's their public key, right? So that public key is where it will be stored. I didn't get this point that where from where the person will fetch the public key of whom the data
Okay, okay. So
he or she has get the point.
right. So there is something called just erase this. So there is something called like public key infrastructure. So if you so in usually in networks, right, say you have 100 users, okay, the private key of each of these users would be secret, okay, whereas the public key of each of these users would be present in a data structure like or like a database or something. And say if I want to, so say the user A wants to send some message to user C, okay, using this public key and private key, like I want to sign a message or something, then say A wants to sign a message and send it to C. A will use his private key to sign the message, okay, so the message plus the signature would be sent to C. What C will do is it will go and query the database to find A's public key. So the public key need not be secret. It can be given, it can be just stored anywhere. Okay, it can be just broadcasted to all the other users also in plain text, in plain form. So C will get A's user key and decrypt apply it on this signature, and whatever the output is, it should match with this message. And if it matches, then I'm sure that uh, two things, right, no one has tampered with the message, and also it was indeed A only who had sent the message to me, message to C, because the signature can only be created using A's private key, and that is only secret which is known to A. So the public key can be stored anywhere. So usually like they store it in a public key infrastructure, like in a database, and all the public keys would be stored. Okay. Does that answer your question?
Yes, sir. Thank you.
Okay. Someone else had a doubt with respect to this.
Yeah, actually, my question is related to this digital signature.
Right.
Question number 5 of assignment 2. Okay, there they didn't consider the option D. Only they consider option A and C. In option D, it is written that digital signature supports user authentication.
Yeah,
But
I saw those
I,
questions. So I'll answer that now actually.
so,
So what does
so
this digital signature actually, where do we apply it? So uh, A wants to send a message to C, and the interest over here is actually a message block. Say I want to send this message, hello. So this message I should send it from A to C. Now how should I ensure that A is the person I am receiving the message from? How can C ensure that A will take the hash of this message? So say you have SHA-256, right? So SHA-256 of this string hello it will generate, and say it is some hexadecimal like 0FAB, some hexadecimal was generated. Now what A will do is it will use the private key, its own private key, on this hash, sorry, on this hash 0FAB, and then it will get some again some random values, okay, like say EFBC, like that. Now what it will do is along with this hello it will send EFBC. Now what C will do is it will take the public key of A, apply it on EFBC, it will get 0FAB, and when it does the SHA-256 of hello, okay, it will be 0FAB and both are equal, so it's ensured that this signature scheme works. Okay. Now this digital signature, this private key and public key, this is what this digital signature is all about. And the thing that you are sending, right, some, see, when you tell you are signing something, what are you signing for? You are signing some message or you are signing some document, okay, and you are sending the signature as well as the document, okay, whereas user authentication is different. Here actually I'm authenticating the message. The thing which is being authenticated is the message only. So the message is authenticated. Two things we are authenticating: one, A is only sending the message, and the message contents are not being tampered by some attacker. These are the two things that I am authenticating. Whereas in the question that was asked in the assignment, option D is about user authentication. Okay, so user authentication is totally different. So
What
when
then? What do you mean by user authentication? I
so
mean, user authentication. It seems like identifying the sender of the message. I
no,
mean, who
so
sends this message? Then by digital signature only we can assure this thing.
no,
I mean, can you define what is user authentication? Yeah, user authentication.
okay.
User
Say if I
authentication
want
usually,
to, yeah, say if I have a system or something, like the user wants to access that system. So in that place, we term that as user authentication. And the difference between this digital signature and user authentication is that in user authentication, right, the user has to be present at the time of verification. As in, like, say, I want to log in into my email system, right? It should be an interactive process. As in, I should be at present, I should be there, and I should be keying in the password, sending it to the server, and that will be verifying whether I'm the correct user who I
Yeah,
claim
I
to be.
got it. That you were talking about in application level, say for email or whatever, Facebook login, user authentication in that
Yeah,
sense.
yeah.
But in cryptographic primitives, what I understood that user authentication, I mean digital signature also supports user authentication. If I sign a message using my private key and you able to verify using my public key, then you know that I am the person who sent this message. So
So, so that is actually message authentication. So as part of that, you claim that the user who you are receiving the message from is indeed the one you are expecting from. So here it's just like a play of words, like slightly confusing. Yes, I agree to that, but this is that the thing that what you are speaking about user is with respect to the message being sent. The general term, if you take user authentication, is there is no concept of message or something. It's just a user wants to authenticate himself themselves,
okay,
right? So here
okay,
actually in
fine.
digital signature you have the object as in the message, right, which is being transferred, whereas
Then
in
for user authentication, to implement user authentication, which cryptographic primitives will be suitable? You think? I mean, it is an encryption. It should not be an encryption scheme. I mean, application level, it's okay through password or user ID password, those kind of stuff. I mean, using cryptographic primitives, which can be used to implement user authentication.
uh, okay, which can be used, you can use the, so instead of the user ID password you are asking for a cryptographic implementation.
no, sir. If I understand the question, he is asking. So when we are entering the password in while logging into any system,
Right.
so what encryption technology is used to pass that password and user ID to the actual server, right? Am I right, Devendra? Is that the question?
No, no, no. Actually, no, I'm not asking that thing. Actually, in
Mhm.
application level, it's okay. User ID and password can be used to authenticate an user. But in
Mhm.
crypto, using some cryptographic primitives, say encryption scheme, message integrity to check message integrity hash is there
Right.
for privacy, encryption scheme is there. But user authentication is another requirement like non-repudiation. So user authentication, I think digital signature supports this user authentication scheme. As there are a lot of books of cryptography, the authors written in this way. So digital signatures, I think it supports user authentication. Anyway,
Right. It should be. It's not like directly supported, as in that it should be slightly tweaked, as in the thing whatever was explained as part of this lecture, right? The proper digital signature that won't directly support user authentication. It will be used as part of a protocol or something. Like there'll be like a couple of rounds where the user
okay, fine.
authenticates to the server that it's indeed who they claim to be, they want to access the system.
And I have another doubt regarding the question number 1 of assignment 2. Okay,
Right.
so you can, right now you don't need to explain it, but if you have some time after this season, can you please elaborate the question number 1 of assignment 2? Okay.
Okay, I don't have the question at hand. I'll try to get it once I finish these things. Okay.
Okay,
But
fine.
many of you have raised a doubt that that decryption function is not being mentioned in the question,
Actually,
right?
there is a problem with question number 1, I think.
Right. So
That's why
actually, that is with respect to public and private key, right? RSA or some public-private key scheme. Okay. So usually
Yes,
in a public-private key scheme, there is no difference between the encryption and the decryption function. So in the question, it was written D, E and D as encryption and decryption function, but logically speaking, both will be the same. It just depends on whether you are encrypting using the public key or you are encrypting using the private key.
now, I have another issue with that question. In first line of that question, it was written that probably Alice was sending the message to Bob, and in the later part, I found that it is written Bob was sending the message to Alice.
yes, and the
So
options also look like they are given for the scenario where Bob is sending message to Alice.
Okay,
The
I'll
answer
I'll
was
have a look at it and I'll contact the uh, NPTEL team, that the team who set the question. Okay. So
all right. Also, sir, in assignment one, question number 10,
yeah, so two
we are
questions.
yeah
Question
two
10.
yeah.
Question 10 in week 1 and question 7 in assignment 2, I guess, if I'm not wrong.
Mhm.
These two questions had a typo, I checked. So I have raised that issue and it will take some time, but mostly should be getting marks for them.
All right.
okay,
Okay.
thank you.
Yeah, okay. So I guess some delay in updating the marks and all. Okay, so here we have another question. Any doubts in the previous question over here?
No, it's okay.
Right. So in that case, let's move to this. So the question is about birthday paradox and the probability that. Okay, so okay, I guess in week 1 lecture, professor has explained about the birthday paradox with respect to hash function. Okay, so let me just. Okay. So in this thing, right, the main this birthday paradox is nothing but, say you have a hash function, say SHA-256. Okay. So any first let's there are many questions with respect to hash function. So I'll explain this hash function concept in general first, so that all those questions also get answered. So hash function is nothing but you get any arbitrary length of string. Say you get like a 1 GB file or something. When you apply the SHA-256 on this 1 GB file, it will output a 256 bit output. Okay, and this and the properties of what this hash function is that, one, it should work on any input, work on any size input. It can be 1 GB, it can be 5 GB, it can be anything, it can be any arbitrary input. Okay, so this is what the first property of any hash function should be, and the output should be fixed. Okay, the output is fixed length, as in for SHA-256 it is 256 bit hash value, uh, which would be the result when you apply on any input. So the output is fixed length, and the third property is there is pre-image resistance. So what I mean by pre-image resistance is, you take this hash function as like h. Okay, so this h is the hash function, and your message whatever I want to hash is x. Okay, and that gives you the output y. So this y is say 256 bit with respect to the SHA-256, and this x can be of any size. It can be 1 GB or 2 GB, like that. Now, what does pre-image resistance mean is, I say an attacker gets to know why he sees this 256-bit hash. By brute force or by any way, he cannot find out what this actual x was. He cannot reverse. There should not be any function such that when I apply this y over here, it should not give me back this x. So my hash function, this head should be what is called as a one-way function. As in, if I apply x, it should give me y, but I should not have any other function where if I apply y, it should not give me x. So this should not be there. This should not be feasible. Okay. So these are the three main properties of a hash function. Okay. And there are other security properties if you take a hash function. So number 4, it should be like one way. So these three are compulsory. All hash functions should um, satisfy these 4 properties. Now the fifth property is something called uh, collision resistance. Okay. So in collision resistance itself, there are 2 types. One is weak and the other is strong. Okay. So in a weak collision resistance, what property should be satisfying is, say I have a message X. Say I have a message X, okay, and I know the hash of this X. Okay, I hashed it, I got Y, and now it should be impossible to find some other message Z such that the hash of Z is also Y. Given this thing, right, given a known message and this hash, I should not be able to find some other message Z which when hashed gives out the same value Y. Okay, so this is what is weak collision. And so where this property would be useful is, say say Alice is sending some message to Bob. Okay, say it is telling like some critical information, as in it's telling like I sent 1,000 bitcoins or something, and it's sending the hash of this message also along with this message. So assume the hash is something like f e, something like that, just some arbitrary number of bits, okay, denoted by y. So later on, um, when Bob checks that he hasn't received 1,000 bitcoins, instead he has just received 10 bitcoins, right? If he goes and tells Alice like, hey, you told 1,000 bitcoins and you send the hash of that message also, but it's not yet received, then if Alice is the bad guy over here, okay, if Alice is the bad guy, what happens is Alice can find out some other message Z, okay, such that hash of 1,000 is also Y, and also hash of 10 is equal to Y. So Alice can tell that it sent 10 as the message instead of 1,000, and since the hash value is also the same, this Y is the same, there is no way to identify whether Alice is telling the truth or not. Okay, so that is what weak property is all about, the weak collision resistance. So a hash function, if we tell it is weakly collision resistance, then what it denotes is that it is difficult to find, okay, like as in it is difficult to find, given a message and its hash value, it is difficult to find another new message which has the same hash value. And if I want to find such a new message, right, it will take 2 to the power m minus 1 iterations if I do like a brute force. and this m is nothing but the number of bits in your SHA-256 hash value. Okay. So any doubts in this weakly collision resistance? Any doubts?
So if you don't mind, could you like answer a question for the answer a question for the previous question?
Yeah, sure.
So just a single doubt, like what if Alice sends like a wrong public key to everyone and then tries to sign it with the original private key,
No, that won't be. Okay,
but
wrong
the key generation is with Alice, so she
right.
can generate any.
Uh, it sends the wrong public key. Okay, so if it sends the wrong public key, right?
Yes, sir.
In that case, what happens is there will be like not only allies, but say other users. Okay, and all these are honest. And before they add it to the blockchain, they will ensure that when I apply that public key on that signature, it works properly, as in it decrypts or that thing works properly and it gives the expected message or that hash of that message. And
Okay, sir.
only if that condition is satisfied, they will include it in the blockchain,
Okay, sir.
right? And
Yes.
yeah, so they won't just blindly accept if Alice just sends some random uh, value and tells it's a public key, but they will check these things.
Yes, sir. Thank you, sir.
Yeah, good question. So this is what, so coming back to hash function, right? With respect to collision resistance, this is what weak collision resistance is. Now coming to strong collision resistance, strong collision resistance is nothing but you have a hash function h, and the attacker should not be able to randomly find, should not be able to analyze the hash function how it works, and should not be able to find any arbitrary two messages x and y such that sorry, x and let me change this, x and z, such that the hash when I apply to x as well as z, both will be equal to y. Okay, so this is what strong collision resistance is all about. So the difference between weak and strong is that in weak collision resistance, the attacker has a constraint that the x is already fixed and the y is there. I should find out a corresponding z which gives out the same hash value. Okay, and in a strong collision resistance, there is no restriction on the attacker that on the value hash value that has to be produced. The attacker can come up with any two messages and uh, such that when applying the hash on these two messages, it will be the same hash value. So why is this an issue is that say the same thing, right? Alice, right? um, Alice is sending some message, so it has to send two messages to say Bob and Charlie, right? It can find, say it has to send a message, say um, um, the contents of the message are same or something like that, but what Alice can do is it can change the it can get two versions of the message such that the meaning is somewhat slightly changed but the hash value would be the same. Okay, so the main security properties with respect to this collision resistance is the number of iterations that the attacker has to go through before he can find any such message which gives out the same hash value. Okay, so for a weak collision resistance, if they have to do a brute force, it's around, I guess, 2 power m minus 1. And for a strongly collision resistance, it should be 2 power m by 2. And where this m is nothing but the number of bits in the hash output. Okay, 1 second. So I have an example about this weak and collision resistance. So a real world example for this weak and strong collision resistance is, for weak collision resistance, as I mentioned, there is this forgery example. Okay, so as in forgery, as in say um, the attacker generates, say Alice is sending, Alice wants to send a message, hello, uh, to Bob. Okay, and it sends the hash also. Later Alice can, Bob is expecting an hello, but later Alice can tell it's not, it has not sent the hello, it's sending some other message, and it would have found some message h or y such that, uh, like say bye or something, such that when applying the hash it will be the same hash value. Okay, so that's the constraint on this weakly collision resistance. For strong resistance, a real world attack is, um, you would have come across this scheme called blind signature, right? Professor would have explained blind signature with respect to a signature property where, say, Alice is there and it is having some message M, and it has to get signed by Bob. So Bob has to sign this message M. Okay, and this signing will usually be on the hash of this message h of m. Okay, so what Alice can do is, it can generate a message m, such that, say, if I want, I'm writing a letter. Okay, so a letter, say, like, hello, how are you? This is the message. Okay, and in this message, say, if I add some extra commas in between, or if I add some extra spaces in between, okay, I can determine what the hash value is. Alice can determine the hash value as, say, 0 FBA, and it has also found some other message, okay, such that specific hash value is the same as 0 FBA. So now what Alice will do is, it will send the message, hello, how are you, to Bob. Okay, Bob will sign that, and now when it is sending a message to, say, Carol with Bob's signature, what Alice can do is, instead of sending the original hello, how are you message, it can send some other message with this sign, and the sign is on the hash only, and since the hash of both these messages are equal, applying the public key of Bob to verify the signature and checking the integrity of the message, everything will fall in place, and Carol will not know that Alice had cheated and sent a different message itself. So the strong resistance and weak resistance, they do not they enforce they do not allow the attacker to perform these type of attacks in an easy way. And so this number of bits in the hash output, right, this 256 bits or something, that will determine the complexity the attacker has to perform, the number of iterations on average he has to perform to find out a colliding hash. Okay, so to find out the list of all messages, right, so on average, to find out any two messages that has the same hash value, you should traverse at least half of this 256 bit output space. So which is 256 by 2, which is 2 power 1 something 128x. So this much of iterations on average the attacker has to traverse, like he should be changing the message and checking whether the hash value is same or not, and this cannot be done so easily. So this like computationally intensive. Okay, and for weak resistance the attacker has to perform 2 power around that's 2 power m minus 1, so which is nothing but 2 power um, 55 iterations on the average. Okay. So these many times of iterations the attacker has to be iterating to. And if you know in the real world you would have come across some hash algorithm called MD5, whose hash output I guess is 32 bits, or I guess 128. I'm not sure of MD5. 32 bits I guess. Okay, 64 bit or 32 bit. Yeah. So the digest size is 128 bit. Yeah. So MD5, the output of the hash would be 128 bits, and around a few years back, it was deemed this MD5 was not pre-image resistance, and all these collision resistance were happening frequently in MD5, and the reason being this complexity to find any two inputs which has the same hash value. With increasing computational power, it became very easy for the attacker to iterate over all the possible messages and find out two messages having the same hash value. So based on this complexity, right, to find any two messages based on the strong collision resistance, so 2 power 128 by 2, which is 2 power 64. So this 2 power 64 iterations was pretty easy in today's computing age, right? So they could easily go through all the possible message variants and find out a pair of messages having the same hash value. So that was so it was recommended that MD5 be deprecated. Okay, so this is
So why,
real world. Yeah,
sir, why are we dividing by two? I don't think I understood that.
sorry.
So it's a 128-bit digest, and we to decrypt it we are using 2 to the power 64, right? We are dividing 128 by 2.
Yeah.
Why exactly 2? It's
So
I
the
didn't
thing
understand.
is, I'll just erase all these things. So in a strong collision resistance, okay, the idea is I have to find two messages x and y. Sorry, x and z, such that hashing both it will give me y. H of x will be y. H of z also will be y. Okay, so it is so you can do a you what you can do you just have to traverse the on average you should traverse the half the number of uh, so there is a mathematical proof. Okay, so on average the attacker has to traverse 2 power m by 2 iterations. So this is like a mathematical proof is there, like why it's enough to traverse these many iterations, and by the end of these many iterations, you'd have most probably found out two messages having the same hash value.
Okay. By brute force method, that is.
Yeah, by brute force method. So this is like somewhat like an average number of iterations. Okay. So this depends on like some probabilistic distribution and those formulae. So they derive this value 2 power m by 2. Okay. So this is the thing, and this m over here is the number of bits in the output. So this is what strong resistance is all about. But in a weak resistance, this is not the value. This is 2 power m minus 1. The reason being, in strong resistance, you can find any two messages, but they should have the same hash value. Whereas in a weak resistance, you are given a message, okay, and you should find out um, a message having that same hash value. So it is 2 power m minus 1. This one is also like mathematically proved. So if you are interested in this proof, right, I suggest you go through this book, Cryptography and Network Security, by William Stallings. So in this they have explained this proof, 2 power m by 2 and 2 power m minus 1, how they arrive at this proof given the number of bits in the output. Okay. So these are the security properties of any hash function. So one is it should work on any input size. Second, it should the output should be the constant fixed length. And third, it should be a one-way function. So given my hash value, I could not determine what my input message is. Okay, and also the third one is it should be collision resistance. That is the no two messages should have the same value. It should be difficult for the attacker to find other than the brute force way. Okay, so that's the these are the properties. And coming to birthday paradox, what they mean by birthday paradox is, so this is something to do with say I have total number of days in a year, right? It is 365. Okay, and if you take um, say 100% or something, right? The probability that any two of them having the same birthday would be like having a high probability. So the probability of any two of them, okay, so this in a total number of students, and probability of two among these 100 students having the same birthday, okay, will be greater than some percentage. So it's usually like 0.5, I guess 0.5 or something. So this thing over here is parametric, this k. So what this happens is, say if I increase the number of the student range, right, and if I want to find out any two students who will be having their birthday on the same day, with increasing k, my probability will be exponentially increasing. Okay, so that's what the birthday paradox is about. And why, how is this related to your hash function um, is with respect to this strong collision resistance. And how is this related is, say this hash function, like any mathematical function, there is something called as the domain and range. Okay, so domain is what all input values can be applied to this function. Okay, so here I have mentioned the hash function can take any size input. So it can be 1 GB, it can be anything. Okay, so basically like there is no limit. Okay, whereas the range, that is what all outputs my hash function can produce. The outputs I have mentioned that it is always 256 bit output. Okay, So this is what the range is all about. Okay. So here the total all the possible values in this range would be 2 power 256. Okay, so 256 bit value means all possible values in this range, the total number of values is 2 power 256. And in the domain it can be any size inputs, so my input length can be 1000 or it can be 10 power 8 also, like 1 million or something. Okay, so in that case all the input space, like all possible input values, the number of input values would be say 2 power 10 power 8, like that, such a huge value. And this value is of course greater than your output field. Okay, so definitely what happens is this the hash function is say you are sending a message hello, right? You are pretty confident that no other message when I apply to that same say some different input, it won't give that same hash value corresponding to the hello message. So you are having that fate in your hash function. But the reality is that since the input space, okay, any input can be passed to your hash function, and the range is just fixed to 256 bits. Uh, this property that the hash of the input is unique to that specific input is actually false. Okay, so that is not the case in any hash function. But what they by this birthday paradox thing, what they prove is the number of iterations to find such a colliding message having that same hash input is 2 power n by 2, which is nothing but to mention that the hash function is strongly collision resistant. Okay, so this birthday paradox is nothing but it's related to the strongly collision resistant property of a hash function. And the idea behind this is the input space is humongously large compared to your limited output space of the hash function. And by all means it will be possible in the future that any input will be like, if you just keep on traversing or something, you will definitely hit across some input which will give out the same hash value of some previous message. But the probability of that happening would be depending on the size of your depends upon the size of um, the output, that the hash output. So in future probably like the hash output instead of SHA-256, right? Nowadays they are using SHA-512. This is preferred, and there are other SHA algorithms like hash algorithms also. So one important parameter in all these hash algorithms is the number of bits in the hash output. Why it is important is because of this rule of this birthday paradox problem and all those things. The brute force attack, in order to stop the brute force attacks, the number of bits in your hash output should be large enough to prevent these brute force attacks. uh, any doubts in this question?
No, sir. Thank you.
Okay, so in that case let's move to the second question, sorry, the next question. If the blockchain is decentralized and everyone is maintaining a copy of it, who will maintain the server or cloud to store the? Okay, so here actually everyone are maintaining the blockchain. It's not like a single server or something. Every node would be maintaining the database or the blockchain. So it is up to the nodes expenses to maintain that blockchain, as in the storage expenses and all those things. So it's not like a single server that is being hosted. Okay, so it's replicated across every node. So say it is like a 180 GB blockchain. The whole blockchain size is 180 GB, means This 180 GB blockchain would be replicated across each and every node participating in that network, in the blockchain network. So here actually storage is not the primary issue, decentralization is the primary issue, but you can try to minimize the information that is being stored in the blockchain and storing some part of it outside also, just maintaining the hash, yeah, in the block. Any doubts in this question?
No, sir.
Okay, thank you. So someone has asked a nice question. Uh, Blockchain is electricity, Bitcoin is like an equipment using those thing. So is blockchain one of the technologies best way to design Bitcoin or cryptocurrencies? So this blockchain, right? This nothing but so um, this blockchain. Okay. So this blockchain is like the that structure it is being used is you have a block, you're storing a hash, and if you want to add a new block, right, you should have this say this is b1 hash. Okay, so it should have b1's hash, and also it should find a hash. Okay, it should hash the contents of this entire block along with b1's hash, and that will be a b2's hash. So let me be clear. So this is block B1 and the hash of the whole thing, say it is 0FA. Okay. And now for B2, for including a new block B2, right? The contents of B2 would be all the transactions or anything, whatever data it has to be included in block B2 along with the previous block's hash value 0FA. Okay. And the overall hash of this entire thing, right, all the contents as well as the previous blocks hash will be b2's hash. And now if I want to add a new block, say b3, it will be b2's hash plus the content, and that will be b3's hash. Okay, so like this, you'll be adding all the blocks, and the difficulty is if you want to change any of the block in between. Say if I want to change B2 or something, right? Now say 100 blocks have been added. It is now in B100. Okay, so the thing is, if I want to change B2's hash, right? You have to compute the hash of all the 100 following blocks is also. You should redo the computation because this 0FA's value, right, is included as part of B2's hash, and this B2's hash will be included in all the following blocks hash. So this is what blockchain is. Now instead of having this block type of so here it is a block and it is being chained together, so that's why we are calling it as blockchain. Now instead of this data structure, there is something called as a graph structure. Okay, so this is called this is used in a blockchain thing called IOTA. So actually, this blockchain, the technical meaning corresponds to this particular data structure, but in a general way, it just refers to all these. When you say blockchain mechanisms, it just refers to any sort of this decentralized consensus mechanism like that. So IOTA is also like a blockchain scheme, but underneath it doesn't use this specific chain like structure to store its block. Instead it uses something called as a DAG. So here you will be having blocks, but it won't be having this linear structure. Instead it will be having this DAG, like DAG is nothing but directed acyclic graph. Okay, and say this is your DAG. If I want like consisting of blocks, say 1 2 3 4 5 6. Okay, and say if I want to add a new block 7, I will be adding it to say 2 over here. And what this will happen is uh, this block 7 will validate block 2 like that. So instead of having like a linear list of the blocks in a chain, IOTA uses a directed acyclic graph. And in some other blockchain, like the overall like the blockchain techniques, right? So the underneath structure might be different. Instead of a DAG, they can be using like a hash structure or like a hash graph, all those things. So there's a separate research field going into how to efficiently store these blocks such that um, you can parallelize some aspects of the blockchain. So, for example, if you say two nodes are there, and if both the nodes want to add some block, right? How can I add such that both the blocks get accepted into the block chain, into that thing. So, in a Bitcoin, if you notice, there is something called as fork. So in Bitcoin, what happens is, say if you have a block 1, and if two nodes are there, and if both the nodes propose two different blocks, okay, say it is one node is proposing block 2 and the other is proposing block 3, what happens is finally only either of these one node, one block only would be accepted, because it depends on the other nodes which block they are receiving, and say this all the blocks following blocks are being added to this chain right over here. Okay, so I'm adding 4 and up till 100 it is being added over here. Then in that case, this is the longest chain with respect to Bitcoin. Okay, and this block 3 would be removed from the chain. This won't be considered. So this Bitcoin is sort of a serialized way, like as in only one chain is active, and ideally only one node is can add a block at a given time. Whereas if you want to make it more scalable, as in other blocks, other nodes should also be adding the blocks at the same time, right? In a given second, I should be able to add 100 blocks or something. This sort of a linear structure of storing the blocks should not cannot be followed. Instead, this type of DAG structure or like a graph structure or any structure can be followed, where the blocks can be added independently. So while some node is adding this block 7 over here, another node can be adding block 8 over here independently of this, and later the other nodes can sync up with them. So there should not be any bottleneck. So the underlying structure would vary, and and it is not this design of blocks being chained linearly, right? This is not the best way, as in it's not the only way to design Bitcoin or cryptocurrencies. There are other data structures also that can be used to design Bitcoins, design cryptocurrencies. So any doubts in this? Okay, so in that case, let's move. Yeah, any doubts? Okay, so in that case, let's move to next question. It is pretty straightforward. What does blockchain mean, and how does it differ from crypto? Okay, so crypto is nothing but the cryptographic schemes that you are using. Blockchain is the one that is using the cryptographic techniques and to ensure that a ledger is being created and it's tamper proof. So that is what blockchain is all about. And cryptography enables us to implement blockchain and ensure that it is not tampered with, and all those um, integrity of the messages and all those things are maintained using cryptographic techniques. I guess this is a pretty easy question, so let me go forward with the next question. Can we send large files like PDF or image, videos, etc.? You can send, but the thing is, since your blockchain is replicated across all the nodes, sending large files like PDF, images, or videos might be a wastage for say this PDF file is around 10 GB, okay, and like that your everyone wants to store some PDF on the blockchain, then the storage requirement will be so high, because your someone had asked the previous question, like would the storage requirement be high on the blockchain. So these are all cases where the storage requirement would be very high, because the blockchain is replicated across all your nodes, and the if you are storing the each PDF file in each node, right, all these 100 PDF files or something, it will take up so much of space. So instead of just storing the files, so instead of storing this 10 GB file just like that, instead what you can do is you can store the hash of this file over say FFP or something. So this 256-bit hash, okay, like if I assume SHA-256, this 256-bit hash value alone I can store it on the blockchain, and the actual file I can store it somewhere else. So that where um, I need to store the actual file depends on what my use case is. If I am the only one who needs to access the file, and like say like just certain say some 10 users or something, they only want to access this PDF file, they can just store it in a centralized server or something central among those 10 users, and just store the hash of this file alone on the blockchain. And the advantage is that they can all ensure that no one has tampered with the file which is being stored in that central storage, and also that file whatever is there, it will just be there in that central server, okay. So it's sort of like you make use of blockchain to ensure that no one has tampered that file with. Or else, instead of storing it on a central server, you can store your file in a distributed database. So you would have come across this term called torrents and all those things, right? So these are all like decentralized distributed database, but where like say um, uh, you have a file or something, you are storing it in the torrent, say someone else wants to download, means they will connect to the network peers who are part of this torrent network, and they will be sending you the requested file. And the issue in this approach is you might not know whether the ones who are sending you that file from that decentralized storage are sending you the proper file, or some corrupted malware, or some file which has been tampered with. So to prevent those things, what you can do is you can store the hash of the file in a blockchain, and you can be ensured that that hash won't be tampered with, okay. But when you get the file from the torrent peers, you can compare the hash of that file with the one stored in the blockchain, and if both are equal, you are sure that whatever you received from the distributed database has not been tampered with the help of blockchain. So any doubts in this question?
What is torrent peer?
Right,
And
so
sir, you said that and storage will be not be the issue. So
right, so what I meant by storage is not an issue is, if I want, so blockchain is not meant as something which provides you data, okay. It's not something like an use like an SQL database, where the main aim of blockchain is you query the database and you get some result back. That's not the concept of blockchain. The whole concept of blockchain, it provides you with trust, and by trust what I mean is that the blockchain whatever it's maintaining, right, that chain of blocks, that is tamper proof. So this thing of sending in large files like PDF images or video, you can send it via the blockchain, but usually it is not done in this way, because that's not the actual service of a blockchain. If you want a reliable way of getting this right, as in you want your uh, there is no one stopping you from sending large files on the blockchain, okay, but the only issue is all the other nodes should also be storing these large files, okay. So in the interest of all the users, what is usually preferred is, instead of having the file itself stored on the blockchain, you will be storing the hash alone. So by the statement, what I meant storage is not a bit of problem over here is assuming that they are just storing the hashes and all these things. So if they are storing the actual file itself, then storage is a bit problematic, because you can have any arbitrary sized file, and that will be an issue because you have to replicate it across all the nodes. So in that case, your storage is problem. It's there should be a limit on the storage. Does that answer your question?
Yeah, answer what about torrent peer?
Okay. So torrent is nothing but um, it's a decentralized distributed database sort of such, like so torrent thing is actually like peer-to-peer file sharing. Okay. So say I'm having say I'm having some file or some PDF document of size 10 GB, okay, and what I'll be doing is there'll be like 100 nodes as part of these. Assume there are like 100 nodes, one, two, like that, and all these 100 nodes would be connected to each other, and parts of some of these 100 nodes would be having a particular file. Say this, I want a book, cryptography and network security book, okay. So among these 100 nodes, say 10 nodes are having this book, okay. What I'll be doing is I'll be querying this network, asking like whether anyone has the book or not, okay. So this is just like a layman's explanation, and among these 100 nodes, whoever is having the book, they will respond to it. And instead of say like 5 nodes are having that book, say nodes 1 to 5, instead of just one of the nodes sending that full PDF file to me, what they will do is they will split up the message into multiple blocks, and they'll be sending parts of that message back to me. And finally, when I arrange all those messages together, it will be my whole PDF file which I was expecting. And this peer-to-peer file sharing is actually decentralized, and it doesn't have like a central server or something. You can just have your laptop or system, and you have to run a software, torrent software or something, and whatever files that you have, you should be sharing it with others and all those sort of stuff. So this torrent thing is actually like a precursor to blockchain, as in when we tell like distributed database is centralized and all those things. This torrent is the quite opposite. It's like decentralized distributed database, but the only thing that was missing in this setup is there was no trust. Like the nodes that is sending me the file, I do not know those nodes beforehand. They can send me a corrupted file, or they can send me a computer virus also. So that was the limitation of using torrent. But now with blockchain, you can store the hash of that file in the blockchain and ensure that the file, whatever you are receiving from torrent, is not corrupted or something. Does that answer your question?
What about a ledger system? It is.
Sorry. Okay, I guess it's answered in question 25. Please give an example why blockchain can't be considered as purely a distributed database. I guess I've discussed this in my previous live session. Distributed database is like centralized, whereas blockchain is usually decentralized. And the whole concept over in blockchain is you are providing with trust, whereas in a database it's like sort of like a you ask a query and you return back the response. Say like how many you'll be storing it in a table form like an SQL table or something, and you'll be querying it and you'll be getting back the values. That's what database is all about. Whereas blockchain is different. It's not providing you data, but it's providing you trust. So that's the high level overview. Anyone has any doubts in this question? I had discussed it in the previous live session also. Okay. Then in that case, moving to, so here Firdaus has asked a nice question. So distinct, what she has asked is when the first block of transaction is created, how is it validated? Okay. So usually in say in Bitcoin, right? What are the you have block B1 followed by block B2. Okay. And say if I want to add block B3, if I want to add a new block B3, it should be that the hash should be combined, and there are some rules to add this new block B3, and also all the transactions. So I'm talking with respect to Bitcoin. So all the transactions as part of this block need to be validated, as in whether the sender is correct and whether the receiver is correct and all those things. But the first block in Bitcoin, how was it created? So this first block is known as the Genesis block, and the address of this Genesis block is somewhat baked into your consensus code. So if you remember previously I discussed the consensus code is something which does the block adding and all those things, right? So the consensus code has the Genesis block pointer. So at the start of the Bitcoin, this block, Genesis block, um, would be empty. It would just be providing some it would just be the address of this block and all those things, right? Address as in the hash of this block, the contents, everything would be just hard coded, and this would be baked into your consensus code, and any block which has to be added to the blockchain will be on top of this Genesis block only. So this is actually this is somewhat like an assumption, and the Genesis block is part of your consensus code. It is not validated as such. Any doubts in this question?
Sir, is there any chance to misinterpret the Genesis block, sir, when it is initially created?
Right, good question. So, is there any chance to misinterpret? No. So each uh, variety of blockchain, they have their own way of specifying this Genesis block. Um, so the assumption is that this Genesis block should be the correct one. If it is misinterpreted or something, it's basically that there is a whole new blockchain, which a new Genesis block, say NGB, new Genesis block, and a whole new blockchain is there, B2 prime, B3 prime. So this defeats the whole purpose of blockchain. So this Genesis block should be the correct one, and we should ensure that it's the correct one, as in like it. So that's why it's baked into your consensus code, and for everyone who's say you want to um download the Bitcoin software and become a miner or someone, right? You have to ensure that whatever code you are downloading is the correct one. So they will be having like um, signed Bitcoin software code and all those things. You should ensure that all those signatures match when you download that code and start executing. because there might be an attack strategy where they might trick you into downloading some code telling that it's the Bitcoin code, but in fact it would be something else, right? It could be like this Genesis block was different or something, and you would be just blindly using that code and mining blocks and adding it to the blockchain, but it wouldn't be adding to this actual blockchain itself. It would be adding to some other Genesis block or something. Okay, so this Genesis block thing is baked into your consensus code, and it is part of your assumptions usually. It should not go wrong, that's it. How we assume that your private key should be secret, right? So in a way we assume that the Genesis block should be correct always.
Okay, sir. Got it, sir. Thank you.
Right. Are there any doubts in this question? No. Yeah, in that case, let's move on. Uh, just hash value rather than the entire message is called message digest. So this message digest is nothing but, yeah, it's the another value for the hash value, and it's the question is pretty straightforward. Another name of the hash value is message digest. So basically, like if I just take the literal meaning of message digest, right, you're providing the message to a function which digests that message and gives out a constant value, a 256-bit value. So I guess that's why they call it as message digest. Okay. So that's what the whole thing is about. Any doubts in this question? It's pretty straightforward. I think the question is self-explanatory. So let's move on. Okay. So what is mining and miners? Please explain it in a bit simpler. Okay. So this term mining and miners. Okay. So this is something specific with Bitcoin. Okay. In specific, if any blockchain technology uses proof of work as the underlying consensus, right? Then this mining and miners come into picture. Okay, so um, the whole thing, the whole no this uh, consensus, right? This term, the consensus problem. Hold on. So this consensus is nothing but you say you have 100 nodes, and each of them are maintaining some state or some say blockchain. Okay, and each of these 100 nodes should have the same blockchain, and if say they want to add a new element into add a new block into that blockchain, then it should be replicated across all the nodes, and they should all agree to add that specific block to the blockchain. So this is what consensus protocol or the consensus problem is in general. Okay, and till now, like in from 1980s till 2000 2000s, right, this consensus problem was usually studied in a permission setting. It was permission setting, as in the 100 nodes would know what the other uh, who are the other nodes in the network, and say if I want to add a 101 first node, like a new node to the existing 100 nodes, right, it should register its public key, public key and all those things. It should register its IP address, all those things, and it should join the network. And I with just having a laptop or something, I cannot just go and access the network. I should first join the network. I should get permission, and then only I can send messages in that network. So this is what permissioned network is all about. And having consensus in permissioned network was easy because you knew the identity of all the nodes present in your network, and to reach consensus, what you could do is you could just take a vote, as in like say if I want to add a block to the blockchain, everyone please vote. And if majority votes for adding, then the block gets added to the blockchain. If they vote against, then the block doesn't get added to the blockchain, and the consensus protocol is simple. That's it. But so, but in a permissionless network, right? So, what's the issue with permissioned network is you should reveal your identity before joining, right, to the network, and say if you want uh, some application where you don't want to reveal your identity but still you want to uh, have consensus among all the nodes, right? So that is the term for permissionless. So say in this e-cash or this digital this cryptocurrency scheme, right, you can be say you're having a phone or something which is um, you're having a system, and it wants to spend some uh, do some transactions or something with respect to the Bitcoin thing. So you're having a Bitcoin account and you want to perform some transactions in the Bitcoin. Okay, so you can join from any system. You should be able to join. Okay, and this is what is known as permissionless. If it was a permission network, right, then you should be there will be some gatekeeper, and they will be checking whether uh, they'll be doing a background check on you or something like that. Okay, and all if all those checks pass, then only they'll allow you to join the network and you can do the transactions. But the central idea of permissionless is there is no single entity like a central server or something like a central logic or like a gatekeeper who is in charge of letting the users join the network in the first place. So that's the advantage of permissionless, and it is truly decentralized, as in there is no gatekeeper who stops you from joining the network. But the issue was that to gain a consensus whether I want to add a block to the blockchain or not, to get a consensus among all the nodes was difficult because you don't know who the other nodes are in your network. You don't know their identity, and that is what is known as like a Sybil attack. So in a Sybil attack, what happens is attacker, like if I just blindly assume that apply the same consensus protocol which I followed in a permission network, say this majority voting uh, decision to the permissionless system where I don't know the identity of the other nodes. Okay, what can happen is um, an attacker can just create different nodes. He can just say having I'm associating each node to its IP address or something. The attacker can just create different having the same node. He can create different identities and simply vote on whatever he wants to, and we cannot be sure that majority voted honestly or something. So the issue is that in a permissioned network we have the rule that one node has one node. Okay, because you know the identity of all your nodes, and you know for sure that the node is um, indeed who it claims to be, and it just has one node to vote for. So it can vote for or it can vote against. But in a permissionless network, you won't know who the other nodes are. And the attacker, what he can do is he can just spawn multiple such nodes. Okay, and he can just try to mess up with this majority voting protocol, and he can just say spawn 1 lakh IP addresses just like that. Okay, using some software technique, right? And he can just ensure that the voting majority voting comes in the attacker's favor. So that same consensus protocol what we are using in permission network won't apply to this permissionless network. So that was a major issue, And Bitcoin solved this issue by implementing something called proof of work. Okay. So in proof of work, what they do is, instead of relying on these voting and all those things, right? What they uh, perform is, they, in order for a block to be added to the blockchain, they tell that any node can add a block to the chain, but the only condition is that it should solve a puzzle, and this puzzle is nothing but a cryptographic puzzle. And this cryptographic puzzle is actually uh, something like, say I want to say I have a message M, right? I have to find a new, I have to find, append this message M, which whatever I want to add as part of the block, I want to find a value R, a random value R, such that the overall hash of the message concatenated with this random value R will give me a hash value such that some k bits, there will be some zeros over here, some k bits will be zeros, followed by the some non-zero value. Okay. So out of, say I'm using SHA-256 hash, right? The first k bits should be 0 and the remaining bits can be anything. So I should find a random value such that when I concatenate with the message, okay, the hash should be having this condition. And what this means is, since based on the properties of hash, right, that is strongly collision resistant, weak collision resistant, all those things, right, there is no easy way, as in like a shortcut way for a node to find this random value R, such that all these k bits in the start of that hash value is 0. So it should follow the brute force way, as in, if I want to have 2 power 70, sorry, if I want to have the first 70 bits to be 0, right, it should at least go through 2 power 70 iterations on average to arrive at a random value R, such that my initial 70k bits of that hash value would be 0. Okay, so for doing this computation, right, the node is spending a lot of resources. It's spending electricity, and also it should be using so much of computational power and all those things. Now, what Bitcoin protocol does is, as part of a reward for solving this puzzle, it will mint new Bitcoins. Okay, it will mint new bitcoins, and this is what is called as a reward. And this reward is for the node which is adding the block to the blockchain after solving this puzzle, after using so much of resources. Okay, so this reward would be predetermined. Okay, as in it will be every 3 years or 4 years, or I guess the reward would be decreasing. Okay, so currently I guess it is around 12.5 Bitcoin or something lesser than that, I'm not sure. Okay, so this is the reward. So every node which adds a block after solving this puzzle to the blockchain, it will get a reward. And this reward, how it is getting generated is, the Bitcoin protocol mints new Bitcoins. Okay, so since it is generating the Bitcoins out of, it just creates it newly, it just mints it newly. Okay, so this process is referred to as mining. So mining is like you just dig out your metals or anything from the earth and get it, right. So in the same way, by solving the puzzle, the node is able to dig out the bitcoins, is able to mint new bitcoins, and have it in his possession. So this process is called as mining, and the nodes which add the block to the blockchain, they are called as miners because they mine the new bitcoins. Okay, so this is the concept of mining and miners, and this concept is relevant only in proof of work consensus mechanism. Okay, and one thing to add in um, uh, this this mining and miners, right? There are other protocols, consensus protocol like proof of stake. So there is proof of stake also. I guess you'll be learning about this in the later lectures. The difference between proof of stake and proof of work is, in proof of work, the assumption is 50% more, the 50, greater than 51% of the computing power should be honest. Okay, because like the node which is adding the block to the blockchain, they are solving a puzzle. Okay, so if the assumption in Bitcoin proof of work or any proof of work mechanism is that the hash rate, the combined hash rate, as in the combined computational power of all the nodes participating in this proof of work consensus thing should be honest, the majority of the uh, computational power. So it can be like 100 nodes, but the majority of the computation, as in like 5 nodes among these 100 nodes, can be very powerful, computationally powerful. So those 5 nodes should be honest for me. Then only I can be safe that the blockchain is not tampered with, and no one would be able to go and change the history of the blockchain. They cannot just go and add some, delete some blocks in the past and add new blocks just like that, because adding such a block, right, they should be solving the puzzle, and then only they'll be adding the they can be changing the block, and solving the puzzle will be computationally intensive, and there will be like considerable wastage of resources. And if I assume that majority of the computational power is honest, then I'm sure that even if the remaining 49% of the nodes are dishonest, um, and they want to tamper the blockchain, these 51% of the computational power, these nodes having 51% computational power, they will be adding blocks to the blockchain at a fast pace, and ensure that the difficulty for the bad nodes to tamper the blockchain is very high, and the cost is very high with respect to the resources they have to spend and all those things. So that is proof of work. In proof of stake, you don't have the concept of miners or mining. There is nothing like that. In Bitcoin, uh, you will be if you Google about like how many Bitcoins are there. Okay, so they will usually tell like some number of Bitcoins are currently in circulation, and there is a cap of 21 million Bitcoins. Okay, so as in like every time a node is adds a block to the blockchain, new bitcoins are being minted and or mined and given to the miner as a reward. And this type of minting, right? It will only take place until in total 21 million bitcoins have been minted, or can it has been mined. And once this level has reached, right, you won't have any mining or miner, you won't have any rewards actually. Okay, so this is the concept in Bitcoin. So the total amount of circulation, like so say if you take Indian rupee, right, who manages the circulation of rupees? It is Reserve Bank of India. It mints the currency notes and it restricts how much currency notes are in circulation throughout the country. So in the same way, this Bitcoin consensus code, right, it will stop minting new bitcoins once the total bitcoin which is in circulation among all the nodes reaches 21 million, right? So that is with respect to proof of work. In proof of stake, what happens is they usually don't mine new coins as a reward to the node which adds the block to the blockchain. Instead, it just the concept is totally different, as in instead of solving a puzzle or something, it they have to stake some um, digital coins from their account in a vault or something. They should just stake some coins, and if they act maliciously, if the node adds different some malicious block to the blockchain or some invalid block to the blockchain, then all the other nodes, on finding that a specific node is behaving badly, they will remove those coins from that node's account. Okay, and the number of uh, digital coins, like, so say like a common proof of stake blockchain example is Tezos, and here the similar to Bitcoin, they have something called Tez. Okay, so this is what their cryptocurrency is called, and the number of Tez which is in circulation is predetermined. It's predetermined, as in it is created at the starting itself as part of the genesis block. So say like around 10 million tests or something is there. I'm not sure. Okay, so all this 10 million tests is created as part of the genesis block, and it would be distributed as part of in some method. It would be distributed to all the nodes or something. Okay, whereas in Bitcoin, all the Bitcoins won't be created in the genesis block itself. As and when the node adds the block to the blockchain, they will get new Bitcoins as a reward, and that will stop once this total Bitcoin reaches 21 million. Whereas in proof of stake, you don't have this concept of mining and rewards. It's just that all the cryptocurrency, that digital coin, created at the starting itself, and when a node adds block to the blockchain, it's not mining for any new coins. It just adds a block in as it just adds a block to the blockchain and checks whether all those signatures and all those things are correct, and it doesn't double spend and all those things, and it will receive a transaction fee. That's it. It don't get this extra reward which is like new coins out of nowhere. So this mining and miners is very specific to proof of work, and it's not which is prevalent in blockchain terminology, as in like it's not applicable to all aspects of blockchain consensus. It's only with respect to proof of work. Any doubts in this question?
Sir, whether it is injustice because who is having more coin only he can participate in POS, and POW really he's doing spending some of the computation power and then he's getting a chance to add it to the block.
So there are two ways we can look at this, right? So if we take injustice, right? So in in proof of work, who has the more computational power, they will be in a better position to add new blocks to the blockchain, right? So in that case, that is one injustice if you consider proof of work. But the advantage is that it is more difficult. If you want to tamper the blockchain or something, you have to spend so much computational resource such that the result you get, right, after spending that much of computational resource in tampering your blockchain would be insignificant. Say, as in like you would gain some $10,000 by tampering the blockchain, means you would be spending $1 million in computational resources itself. So that is what proof of work strategy is. Whereas in proof of stake, the the idea behind proof of stake is whoever has more stake in the in this say Tezos blockchain, say like 100 nodes are there, and whoever has more stake in this blockchain, right, they will be more honest because they have more to lose if this blockchain fails. Say you have two users, one user is having 10,000 tests and the other user is having 10 tests. Okay, so the voting rights or like the staking rights would be given in such a way that the one who has more the idea is that the one who has more tests, right, that individual or entity would be more honest when compared to a entity who's having less tests, because they have more to lose and they will for sure ensure that the blockchain functions properly. Okay, so that is what this proof of stake is. And with respect to injustice and those things, it doesn't even in proof of work there is this computational power and those things, right? So this the whole idea of staking and proof of work is that I have to ensure that my blockchain is not tampered with, and for that, instead of going this computational resource way, I make use of this staking itself such that the one who has more to lose will definitely be honest and he won't allow other nodes to tamper the blockchain. So that is the idea behind proof of stake. And
It is
for
like either you spend energy or you spend money.
yeah, exactly. So energy is something it's like it's very expensive compared to this proof of stake thing. And recently, even like Ethereum has moved to a proof of stake consensus from a proof of work, because the electricity expenses and all those things are so much high in Bitcoin. And also recently, like there has been so if you come across this term called mining pools. Okay, so usually what happens is there will be some organization. Okay, what they will do is say they will just tell you, are you interested in Bitcoin or something, and instead of you as a full node, as in like mining new as in like adding a block and solving that puzzle, what you do is you just um, have, so instead of having say you have a system or something independently, you won't be able to mine a new block and solve that puzzle. It will take a week or time or something, it will take 3 months or something also, based on just your laptop's performance. Okay, so what these mining pools or those things do is they just get all these individual users who are interested to get some reward by adding a block to the blockchain. They get all these resources together and they try solving a puzzle and add a new block, and then they share the rewards among all the users. Okay, so they just lend out their computational resources. So these are like mining pools. And what happens is currently like they have done an analysis, and these mining pools are concentrated in specific regions like China, US, and some parts of Europe specifically. So the whole concept of blockchain or Bitcoin is it should be decentralized, and the majority of hash power should be in different parts of your world, right? They should be honest. But here, if you notice, the majority of hash power is just like in 4 locations or like 5 to 6 locations around the world, and the government or someone can take a step and interfere in these in the way they add transactions to the blockchain, or they can censor some transactions which has to be added to the blockchain. So that is an issue in proof of work, one open issue.
Okay, sir.
Sir,
Yeah.
So where do we find the recording for this in the next previous session?
I have shared a YouTube link in the forum actually.
Okay.
You can find it over there. I'll be adding the recordings in the YouTube playlist.
Okay.
I'll post
Um,
the link again also in the forum.
in the forum. Okay. All right. Thank you.
Yeah.
So,
Yeah.
could I actually ask a question from the assignment?
Yeah, sure.
Sir, in week two,
Just
question
a
number.
second. I'll just finish
Yes,
this.
sir.
Sorry. Uh, Deepa, do you have any other questions with respect to this concept?
No, sir. After spending some amount also of POW, sir, if the particular miner unable to log into the unable to add that his energy gets waste, sir, he will not get
Yeah.
any reward after spending money.
Yeah, he will not get any reward. Uh, so, say one node is able to find a block, it's able to solve the puzzle, it gets added to the blockchain. But somehow the other nodes say like don't accept that block, and they just add a different block to that blockchain, and they start building on that chain, right? So it's like a fork happening, and so we will be discussing forks in week 4. Okay, so in that case that node would have spent, as you mentioned, like should have wasted all its resources. They have assumed that block got accepted, but in reality after some time if you notice that it won't be part of the longest chain, and the node has to again mine a new block and add it to the blockchain. So that is the disadvantage. So around like for every block that is being added, right, around like 10 like billions of hashes are being hash power is being wasted. So that's a disadvantage of proof of work.
Okay, sir. Thank you.
Yeah. Yeah, Kartik, I guess.
Yes, sir.
Yeah. Uh,
Sir, like in assignment two, question number 7, sir, it is asked why is consensus hard in asynchronous systems?
right. So why is consensus hard in asynchronous system is see if a global time is there, right?
Yes,
You
sir.
can easily order the messages. You can in a synchronous setting, right? You can easily have a global time. See, first of all, if you have 100 nodes, how will you ensure that everyone is following the correct time? So maintaining the time itself is a bit of it requires a synchronous setting. Okay.
Okay, sir.
Whereas in an asynchronous setting, you cannot devise any consensus protocol based on time. Okay, so say in an asynchronous setting, you cannot tell like, okay, for 10 minutes, I will wait for all the others to vote whether to add a block to the blockchain or not. That that sort of algorithm you cannot have in an asynchronous setting, because you won't know when the other nodes should respond. You cannot set a bound on the response time. So in
Uh,
that case, the time itself, there is no notion of proper time or something in asynchronous setting. So that complicates your consensus algorithm. So it's not impossible to get consensus in an asynchronous algorithm, but it complicates your protocol. So instead of having a global time or something, you should be something using some timestamp, or not timestamp, like as in a sequence number or something. And then also some blocks you might receive out of order, some messages. You should handle all those things. So that becomes quite hard.
okay, sir. Yes, sir. Thank you, sir.
Right. And since you had asked this question, right, there is a common theorem called the FLP theorem. So, so FLP, I guess. One second. On this. So there is this theorem called FLP impossibility theorem. So this was proved in the 1980s, I guess. Okay, and what this theorem states that if you have an asynchronous network, okay, even if one node crashes or one node is acting in a bizarre way, okay, one node is failing, okay, then you cannot you cannot achieve consensus. So even if one node is failing, right, you cannot achieve consensus in an asynchronous network. So
Sir, but like, couldn't we use some like UTC or like some time constant as a global time for like asynchronous systems?
no, you cannot have the notion of time. So an asynchronous network, the only condition that you can assume is the message will eventually get delivered, but it can be 1 month, it can be 1 year, it can be any duration of time, but it will be delivered after some time. That's the only assumption you can have. Say it can now it will be delivering in 1 second. Later
Uh,
it can be 10 minutes.
Sir,
It will
even
be
for
wait.
not about message passing, sir, but like, wouldn't there be actually a notion of global time? Because like, we couldn't we use like Unix time or like standard time for something and then count from it?
Okay, so see the Unix time. Uh, so assume that each node can maintain its own time. Okay,
Yes, sir.
but the asynchronous network are the is the network in between, right? The medium of communication. So that might be problematic, and the time that it uh, and the usual thing is in an how will you ensure that the time is synced in the first place among all the nodes, right? So you should be sure that all the nodes follow the same time.
Uh,
Okay, there will be variations, and those variations will definitely increase. Like some will be 1 hour minus
so
1 hour.
couldn't we actually like, oh, okay, sir. So does the asynchronous system here mean like we couldn't also access the internet in a like sync manner?
So the network is not synchronous. So having a global time means you should sync up with all the nodes and ensure that the time is same, or at least like plus or minus 5 minutes error. But that itself requires a synchronous network underneath. And here we are having an asynchronous network, so that is an issue,
Okay, sir. Thank you, sir.
right? So this is the FLP impossibility theorem, which states that even if one node is crashing or failing, right, you cannot achieve a deterministic consensus in an asynchronous network. And that's why in all the blockchain problems or any real world blockchain, they'll be using something called a partial synchronous model, as in they can assume that everything works synchronously, everything you can expect your messages in 10 minutes or 1 hour, like that, a bounded time. In between for 30 minutes or so, it will behave in an asynchronous way, but again it will return back to a synchronous setting. Okay, so that is called like a partial synchronous. In between there might be network outages or something, but majority of the time my network would be synchronous. So this is the model that most of the blockchains real world applications would be following, since if I just assume my network to be asynchronous, right, I cannot achieve consensus in any way. Okay, so moving to next question. So they have. I'll just continue for another 5 to 10 minutes and try to wrap up all the questions. The questions are mostly repeating. So someone has asked what's pre-processing algorithm. So I had mentioned that hash algorithm, your input can be of any size. Okay. So but usually for better performance and also for simplifying the algorithm, like the hash algorithm, the input is usually what it is done is it is padded with some extra bytes. say some specific number of zeros or something, such that the whole input size along with this pad, okay, is divisible by some specific number, like say 1024 or something like that. So the hash algorithm, what it will do is it will take the blocks, take this whole input in blocks of 1024 bits and process it and get the hash. The algorithm is designed in such a way. So to perform these, to perform this hash computation, the input size should be, it should be divisible by 1024. If not, it will add some number of bits as a padding to the input such that the whole size is divisible by 1024, and that is the pre-processing logic that was mentioned in the slides. Any doubts in this? So this pre-processing logic will differ with every hash algorithm. So, but the idea is this thing. So it just gets the input, adds some padding, so that this property is ensured for the hash to process the input. So which languages should I learn to write coding in Ethereum and Hyperledger? I have discussed the programming languages before, so I'm skipping this question. Is hash functions used for security purpose? Yes, hash functions are used. Mining, solving the puzzle, everything for integrity of data, everything hash function is used. Can we use blockchain to store crop disease and its remedial solution? Is it that much useful? Okay, so blockchain is tamper proof. Okay, so crop disease and remedial solution, like all those crop genetics, right? So usually, like say similar to how wildlife gets extinction or something, right? Even crops, they have to be grown like these crop genetics. They have some cellular structure and those things, right? So these crop genetics, these data or something, you can, I'm not sure, you can digitalize them or something, and for to, you know, like instead of storing it in a centralized server, you can store it in a blockchain or something, so that it is tamper proof and it lives on in that blockchain forever, that crop genetics data or something, so that the future generation, say some crop gets extinction or something, right, like it's no longer actively um, grown in farming or something, you can use that data to synthesize those crops in a lab or something, artificial synthesis. For all those critical information like this crop genetics and all those things, I guess you can use blockchain to store it in a permanent fashion in a decentralized distributed setting. So it is useful, I guess. Any doubts in this question? Okay, I take that as a no. So someone has asked, as decentralized system used in social media application and what's its benefit against centralized. So if you take the example of Facebook, right, all your social posts, media, images, everything is in just a single entity like Facebook, and suddenly Facebook can just claim that your account is showing some spurious activity or something, and they can just delete all the photos, they can just deactivate your account, and if you don't have a backup, right, all the photos and everything would be deleted when Facebook deactivates your account. But in a decentralized system, there are some real world like use cases where it has being used in a social media application, so something similar to Twitter, where it is all like decentralized, they store everything like in a blockchain or something. But the storage space, I have not read anything about the storage aspect. Usually there would be a limit, I guess, on the size of text that would be stored as part of that, the message size or something which is to be stored. But the idea is, since it's decentralized, and it's stored in a blockchain is like it cannot be easily deleted. So I'm not sure how they can edit any post or edit any tweets, right? So once they post it or something, it's permanent. They cannot edit or they cannot do anything. um, I can look into this and answer how they do any editing stuff. But just naively, if you think they cannot do any editing purpose, but they can just have a log of all the social media posts. And the benefit is it's not centralized, and they just don't have to rely on some central entity like Facebook, and they don't have to trust a central entity and always like they like the central entity they need not be scared or something that the central entity will deactivate their account or something like that. The data will always be there. What exactly is blockchain? I have mentioned it's just like a chain of blocks, and the hash pointer of the previous block would be stored in the current block. So like this. So B1's hash should be stored in B2, and so it's just like a chain of blocks. So this is what literally a blockchain is, and a chain of blocks. Uh, okay, so this question append 64-bit block which is equal to number L, so is actually part of your pre-processing logic. Okay, so all this appending and all this thing is made sure that your input overall input modulo 1024 is divisible but by 1024 or some specific number with respect to your hash algorithm. So all these things are part of your pre-processing step to get the input to the proper size and pass it to the hash algorithm. And what is mod 232 addition? Okay, so here actually it's mod 2 power 32. Okay, so what this means is say I'll explain this with respect to mod 5. Okay, the same is for mod 2 power 32. So mod 5, what happens is I am defining an addition operator such that any number, if I add any value, it should be between 0 to 4. Okay, so say if I'm adding 6 plus 9, and this plus is actually a mod 5 addition. What this means is 6 plus 9 equal to 15. That is the usual addition. Okay, but in mod 5 addition, 6 plus 9 15, I do a mod 5. So mod is nothing but a reminder when I divide 15 by 5, and it is 0. So 6 mod 5 addition with 9 is actually 0 and not 15. So if I do 1 plus 10, okay, normal case it's 11, but if I do 1 mod 5 10, then it's actually 11 mod 5, which is the remainder is actually 1. So the cool thing about this mod addition is, say mod 5, right? Any pair of numbers, any sequence of addition or multiplication you do, right? The final number that you get would be between 0 to 4, which are the possible reminders when you divide a number by 5. So in the same way, when you do mod 2 power 32 addition, all the numbers that you get are for sure within the range 2 power 32 minus 4. So that is what mod addition is all about. Any doubts in this question regarding this modulus arithmetic? Okay, so let's move on to the next question. Okay, so yeah. So actually, what the question was is in the diagram, like there the hash function will be done in a sequence of steps. Okay, like sequence of rounds. This is round 1 and round 2 or something, and all those input blocks over here. So say this is your input, and it will be divided into 1024 bit blocks, and this will be I1, this will be I2, as in like I1 is the first 1024 bit input block, and usually it would start from uh, I0 or something. So this I0 is like a predetermined random number or something like that. It varies with respect to each hash algorithm. So in the slide there was a typo mistake. Instead of um, I1 or something, it was actually I0. So I guess that's what they are pointing it out. So the next question is about what's a compression function used in SHA-256. So the term compression function is nothing but the hash function, like SHA-256 or the hash function. What it does, it takes any input size, say 1 TB file, 1 terabyte file. If you apply the hash, it will give a 256 bit output. So it's basically your size of that input, right? It's significantly higher when compared to your size of the output. So it's doing some sort of compression where the size of the input is getting compressed and you get a unique integer, unique number, 256 bit number, okay, which you can associate with this huge 1 TB file. So it compresses the input since like this, the size of input is higher than the size of output, right? It's greater. So it is compressing the input literally. So that's why it is known as a compression function. Okay. Any doubts in this? Okay. Cool. Then question 39, is there any criteria to apply the type of hash pattern? Yes. Say if I want to send, um, if I'm sending 100 messages, okay. Now instead of I'm sending 100 messages to Alice is sending to Bob 100 messages. So instead of sending one hash per message, what can Alice do is it can concatenate all the messages together and hash them together and send a single hash. So one hash per 100 messages. Okay. So in this way, the hash computation will you just have to send one hash and it just it's the same, like the input size will vary, but your network consumption, those things are all reduced, right? So in that case, that sequential hashing or that type of hashing is preferred. And as such, whether I have to concatenate all the 100 messages together or I should concatenate, say like I hash the first message m1, okay, I get one hash h1, I do h1 concatenate with m2 and get a hash, and that will be my h2, and then I take h2 concatenate with m3, like that. So this is actually more a tiresome type of sequential what's it, concatenated thing of hashing compared to just hashing all the messages appended together, right? So it just if you based on the cryptographic hash properties, doing it this way or this way, it doesn't matter, because if you are sure that it is collision resistant and all those things, and it is strong enough such that the message cannot be tampered with and those things, right? Then you can follow this technique over here. But in this proof of work and all those things, right, you are basically following this technique. So you are including the hash of the previous block, so it's basically like h1 and then you are hashing it. So you are having a chain of hashes, so it is called as a hash chain actually. So this will be like more complex for the attacker to break, because he has to individually find all these hashes and break it, find a corresponding different message, and in order to tamper the message, right? So this would be a bit difficult. compared to attacking this, as in like finding a same message with a different hash. Whereas a totally different type of hash is the uh, Merkle trees, which is nothing but hierarchical hashing. So I would have discussed Merkle trees in previous live session. I suggest you go through that part of the video. I'll just share a timestamp to that section also. So depending on your application and how much security you want, the type of hash pattern might change. So it will change. So moving on to question 40. I'm from commerce background. Whether so this is mostly a technical role actually, and if you sorry, this blockchain course is more sort of technical aspect. So it will you require some technical expertise to study this course. But overall, like blockchain is not just about technical aspects, like that minting new coins and all those cryptocurrency thing, right? They have so much of economics and game theory stuff in that. So even a non-technical person who is into economics and those things, they can definitely contribute a lot to these cryptocurrencies and those things, those financial aspects of the blockchain. So when we append a new block into the chain, how will it be visible to other players? It won't be directly visible. You have to do block propagation. So this will be explained in week 4, I guess. So you have to advertise the block that you want to add to all the other nodes in your network. So is there any difference between the term collision free and collision resistant? I am not sure where this term collision free was being used. If Abhishek Mehta is there in this call, you can unmute yourself and talk. Okay, so I'm not sure where this term collision free is used. The general notion is there is this weak resistance and strong collision resistance, which we had discussed before. So in weak resistance is you just have given an x, you have to find a z such that both hash to the same value y. Strong resistance is you can have any arbitrary pair, find any pair of messages x and x bar such that both have the same hash value y. So here the limitation is you are given a message previously, but here you can get any pair of messages. So this is a stronger resistance compared to this weak resistance. So these are the two types of collision resistance in hash functions. Any doubts in this question?
Hi, sir. This is Saravanan.
Yeah.
Sir, actually, I am also having this same issue. In the video material, we mentioned the feature of a hash function is one is collision free. In the questions, they gave only the option called collision resistance. So still, I am not clear in that two end terms.
Oh, in question it's which is the correct answer then?
That's what they mentioned. Collision resistance also one of the correct answer. So now I would like to know
Oh,
first
okay.
what is collision resistance and how we can compare with the hashing function.
Collision collision resistance is this: two messages should not have the same hash value, and how difficult it is to the attacker to find two messages to find the same hash value. So that is what collision resistance is all about. Collision free, I am not sure actually. I guess this weak or strong collision resistant, right? In that one of those would be called collision free, I guess, in that case.
Okay, which means there is no chance to appear the collision in hashing function.
That no chance, as in it will be difficult to find such a thing, such a collision, unless you do a brute force method or something that will be
Okay.
computationally intensive. It is difficult.
Okay. Okay, sir. Thank you.
Yeah. So the next question is from Anshu. Why blockchain is called trustless? Okay, so this I guess I have answered many times. You don't have a centralized server. Everything is decentralized and there's a consensus protocol. So I'm skipping this question. Uh, this also I answered, like, is it possible to run out of space? It is possible, but you are just storing the hashes in the block rather than the actual transactions data. So currently I'm not sure how much that Bitcoin blockchain size is, but maximum it should be like 500 GB or 600 GB, not more than that, I guess. So yeah. So you don't store the actual files, the PDF file or something. You just store the hash of that file to ensure that it is not being tampered with. That's the main idea of blockchain. It's not a data service. So I've discussed this previously. If you want, you can refer to the recording and see. If wrong data is entered by mistake, it remains in the blockchain. You cannot do anything with that. You can add a new message on the blockchain in the latest block stating that information is wrong and you should ignore that. Maybe that might suffice. But if you add a data by mistake, then it will remain in the block. It will remain in the blockchain. Any doubts in this question? Okay, I take it as a no. Real life applications of cryptography. Okay, so cryptography is, yeah, you can use it in blockchain for all this authentication, integrity, everything. Cryptography is used. So the answer is a bit direct. Everything is based on cryptography in this course. Guarantee that the information added to the blackboard by a player is correct. That is a blockchain. You cannot guarantee that the information is correct. You can just guarantee that later the player doesn't go back and tell, like, I didn't add this information. So that sort of thing is not that sort of, that's called like non-repudiation. Okay, so that is so this thing is possible, guaranteed in a blockchain. So say if a player like as in a node adds a block, adds a message to the blackboard, the decentralized blackboard, um, in the blockchain, adds a message to the blockchain, they cannot at a later stage um, tell that I didn't add this message, because they would have digitally signed and they would have added that message to the blockchain. So the message can be right or wrong, that is a different aspect, but the message authenticate is authenticated always, as in it is not tampered with, and the user who added it cannot deny it later. So that is guaranteed. So the information can be correct or wrong. That is outside the guarantees of blockchain. Any doubts in this question? Okay. Decentralized. So over here they have asked, what's explain the meaning of decentralized, immutable, append only public ledger. So by the term, if you take decentralized, okay, so there is no central entity, okay, which governs the nodes which have to join and all those things. Everything has the copy of the ledger that is decentralized, and by immutable, you cannot tamper the previous contents of the blockchain, the history of the blockchain, tamper history. And by append, what we mean is you can only add elements, you cannot delete, cannot delete. And by public is it is open to everyone, so you no permission to access the ledger or join the ledger or anything. It should just satisfy the conditions. That's it. So this is what a decentralized, immutable, append only public ledger is about. Just take word by word, you will get the meaning. Uh, I'm not sure where Aadhaar card was used in the slides. Is Anshu here, or does anyone have a question, doubt in this question? Example of Aadhaar card or something. I have not gone into any. I have not referred to any blockchain application which stores these Aadhaar cards thing in a secure way or something. If you are interested, maybe I can go through this um, application and discuss it. Is anyone of you interested?
Yes, sir.
Okay, so
And I have seen using these birth certificates are stored using the blockchain, but not the Aadhaar cards, sir.
right. So I'm okay. I'm not sure. Recent like there is a government committee which is looking into this, but it's not. They have not released any white papers or any documents. I just saw a couple of conference papers which discuss these, but it's very like naive solution like that. So the main premise they are advocating is since it's told in a decentralized way and it's like tamper proof, you can easily authenticate the Aadhaar card details by any entity like that KYC document and all those things, right? You can authenticate the Aadhaar card details if you have a blockchain, but I'm not sure how privacy will get affected if you store the Aadhaar card details on a public blockchain, because now everyone can view the details. So this aspect I'm not very sure. Maybe I can just look into some resources and get back.
Sir, but here I heard something, but I am not sure how true is this. Government is concentrating in real estate documentations in blockchain network, so
Yeah,
that no one can do any changes with the parent documents.
right. Yeah, even I have come across news articles like even agreements, documents, everything, right? So yeah, I've come across those. Like I can.
Andhra government already it has done, sir. It has implemented it.
Oh, okay, nice. Is it like a public blockchain or permissioned one?
I don't know the concept behind. Only I've read the news that Andhra government has implemented this for property, getting someone name and all. They have securely
Okay.
made it using blockchain.
Okay, I'll then go through these Aadhaar card and government-based applications and get back uh, the next section. Is that fine?
Sure, sir.
Okay. So in that case, in future, blockchain is completely different. Okay, so as explained, blockchain is different from Bitcoin. Bitcoin uses blockchain and not the other way. Okay, so Bitcoin is an application of blockchain. What problems can be solved through blockchains in our daily life? And is it considered as a replicated data structure? Yes, it is a replicated structure. It's not something for like storing data, but it's the term replicated is mainly to have a decentralized setting. And what kind of problems can be solved in our daily life? It depends on where you want to get trust, and but also you don't have to no central entity. So all these problems, applications, right, where you have to gain trust among all the nodes, but there should not be any central entity. So in these um, applications. So this cryptocurrency is one application, right? So if you want to have a cryptocurrency, digital coin based currency, right? So in that case, these blockchains are trustful, they cannot be tampered with, and also there is no central entity because it's everything decentralized. You don't have a government or something which is looking on all the transactions and censoring those. So applications of those sort, the supply chain management and those things. So even if it's like an industry setting, right, petroleum or the supply chain management is something which affects our daily life. So those are all applications of blockchain in our daily life. So moving to this question, so public and private key pair generated for each transaction, and when the pair is generated, how is it distributed to the sender and receiver? The private key you can, okay, so with respect to Bitcoin, I will be explaining this the next live session. So next live session, I will be explaining in depth about Bitcoin, and I suggest everyone to post your doubts in the forum with respect to Bitcoin and all those things like weekly video lectures. Okay, I'll try answering all the questions next week.
Sir, it would be great if you explain that Bitcoin transaction in detail, so it helps us.
Shall I explain that next week?
Yes, that's it.
Yeah,
Next
because
week, plan accordingly. It would be great if you explain in the Bitcoin transaction, especially.
yeah, fully about Bitcoin only I'll be explaining next week.
Okay, sir.
So because I had asked initially whether I thought of explaining Bitcoin in today's session, but I had prepared for that only. But majority of you like had told like they haven't gone through weekly lectures still. So in that case, it will be a bit difficult to have a head start if I start explaining Bitcoin at this stage.
Correct, sir.
So next week for sure we can explain. That's why I'm going overtime and finishing all the questions in week 1 and week 2. So, so the next question is, will Web3 come under blockchain technology? Yes, Web3 is under blockchain technology. And about Web3, I guess in week 5 or something under Ethereum smart contracts or Hyperledger, we will be discussing. At that time, I guess we can discuss about Web3. And in the example of blind signature, without knowing the contents, if the authority makes a signature, there might be some issues. It means the authority trusts the source of the message sender. My question is, what if the okay? So in this thing, right, the assumption is the sender who's sending the message is trusted, and the signer has to trust that he has to know the sender previous hand, but the condition is the signer should not know the message the sender is sending. So that's what blind signature is all about. Okay, so message sender is a malicious party or something that the signature scheme should the uh, the signer has no control over what message the sender wants to send, but the only property that the signer can do is it can just sign the message and ensure that the signature hasn't been tampered with by using a strong digital signature. So this having a malicious sender or something, it's out of scope with respect to blind signature. I guess this storage question I have answered. How should I proceed with the course? Okay, attend the live sessions, go through all the video lectures, that is more than enough. And if you don't know any concept, be open to Google up and go through various articles, spend some time, and blockchain is like ever it's ever it's a developing field, right? So there are lots of nice articles, you can refer those and understand the concepts in a better way, like uh, yeah, Aditya.
Like, is this course organized by IIT Madras or like IIT Kharagpur? I believe. Like,
IIT
you were
Kharagpur.
actually on your starting page, you wrote like IIT Madras.
Oh
That's why
no,
I said.
I'm from IIT Madras, so I mentioned.
So, you are working here or like this the
Sorry, I'm a PhD student. So,
well, like under the main faculty.
yeah,
Okay, got it. Thanks.
okay. I guess then that's the end of all the questions posted in the forum for week 1 and week 2. So for the next live session, I suggest everyone go through weekly lectures, gather your doubts with respect to Bitcoin, either post it in the forum beforehand so that I can set up a schedule for the next live session such that I can know like which points I should elaborate more and on which concepts I should concentrate more. I would have a better idea and manage the time accordingly. Okay, so if there are no other doubts, then we can wrap up this session. Thank you for attending the session. And I went like around 50 minutes over time. I don't mind you. Um, that would be a problem with you. Sorry for that.
Can you provide the slides, please, or like on the course portal or some sort of like in the discussion forum?
Uh, yeah, I, the slides I can provide, but there's nothing much in the slides as such. It's just the questions only. So
Like for reference, it helps. Like sometimes, like for the revising that stuff, whatever the professor taught.
yeah, sure, I can share the slide link also.
Thanks, if possible.
Yeah, my pleasure.
Thank you, sir.
Yeah, thanks. So see you all next week. Thank you.
Thank you, sir. See you.